All right, it is day 2 of exponents. Yesterday, remember, we learned 2 important rules. We learned that, we'll squeeze it up here, anything to the 0 power is 1. And we learned that when we have negative exponents, it goes in the denominator and becomes positive, or vice versa. Today we're going to talk about scientific notation, which is very useful when you have to write very, and I'll underline very large, and very small numbers. And it may or may not be something you've seen before, but it will be something you see in chemistry, because in chemistry you have some really big numbers. And we're not going to write a 23-digit number. We need a smaller way, a more condensed way of writing something. So before we get to that, let's take a look at, because scientific notation uses powers of 10, let's take a look at powers of 10 and look for a pattern. So we know from yesterday, 10 to the third is 10 times 10 times 10, which is 1,000. 10 squared is 10 times 10, which is 100. 10 to the first power is 10. We learned yesterday anything to the 0 is 1. 10 to the negative 1 is 1 over 10, which is 1/10 or 0.1. 10 to the negative 2 is 1 over 100, which is 1/100th as a decimal. And 1 over 10 to the third is 1,000, which is 1,000th, like that. So notice positive 3, 3 zeros. 10 to the second, 2 zeros, and so forth. Also, that each time, if we decrease that exponent by 1, our place value here goes down by 1 place. In other words, boop, went 1 place to the left. Boop, 1 place to the left to get to the next number. And vice versa, if we increase the exponent by 1, our place value goes up by 1. It might be going this way, right? As we get higher, boop, there we go. And that's what we see in the chart here. As we decrease our exponent by 1, okay, if we decrease our exponent by 1, we're dividing by 10 each time, and our place value is decreasing by 1. Conversely, if we're multiplying by 10 and we're getting larger, then we're moving that decimal place to the right versus this one moving it to the left. Well, let's review some of the things we learned so far. If you want, pause the video, and then when you're done, play it back as I work through all the answers. This is 1 over 10 to the 3, or 1,000th. This is 1. And just like we talked about earlier with that 4, we're going to have 1, 2, 3, 4 zeros. You can put a comma in if you like, but not necessary. 3 zeros, that's going to be 10 to the third. It's negative 1 decimal place, so 10 to the negative 1. Negative 3 decimal places, 10 to the negative 3. Now, scientific notation, now we're finally talking about it. Scientific notation, like I said, very large, very small numbers. It's in 2 parts. The first part, A, is a number between 1 and 10. It can equal 1, but notice it does not equal 10. It has to be smaller than 10, but greater than or equal to 1. Part 2 is always 10 to some exponent n, where n is an integer. And remember, an integer is a whole number, can be positive or negative, no decimals or fractions. So that's a set of integers there. Well, let's take a look at these examples and see if it, well, here, I'll leave that definition up. If it is a scientific, in scientific notation or not. So again, you can pause the video, do it on your own, and then play it back when you're done. This first one, No, because that number is not between 1 and 10, is it? The second one looks good. This third one, no. And the reason it's no is, again, that first number is not between 1 and 10. See, it's less than 1. D, yes, looks good. E, no, looks good, but oh, that's supposed to be a 10, not a 7. And the last one, that is no as well because of that fractional exponent. Remember, it needs to be an integer, no fractions. Well, let's get some practice writing numbers in scientific notation. Now, to do that, we need a number between 1 and 10. So we need that decimal right there. So it's 5.6. 5.6 is a number between 1 and 10. Now, if that decimal's there to get back to where it started, it would need to move 4 places to the right. So this is going to be times 10 to the 4th because it needs to move 4 places to the right. For this one here, our decimal needs to be between that 9 and the 8, so we get 9.87. To get back to where we started, it would need to move, let's look, 8 places to the right. So this is going to be times 10 to the 8th. Now this one here, our decimal needs to be between the 2 and the 3 to make a number between 1 and 10. To get back to where it started, it needs to move 1, 2, 3, 4 places to the left. Okay, don't forget to count the 2 as one place as it moves in front of it. And finally, our decimal needs to be between the 1 and the 2. To get back to where it started, it needs to move 3 places to the left. So 10 to the negative 3. I'll box that answer. Now let's go from scientific to standard. So that decimal needs to move 1, 2, 3, 4 places to the right. 3, 2, 0, 0, 0. See how it went from here now to here? It moved 4 places to the right. And that's our answer. You can put a comma in or not, doesn't matter. This one needs to move 1, 2, 3 places to the right, so 9, 8, 0, 0. This one here, right now the decimal's right here, like $4. It's after the 4. So it needs to move 1, 2, 3, 4 places to the left. We usually put a 0 in front to mark that decimal, but we're going to need 1, 2, 3 zeros and then a 4. See, it started here and it moved 4 places to the left. Oops. And finally, this decimal, which is right here, needs to move 1, 2, 3. So 0.001234 is our answer.